Jessica Kerr is a functional developer on the JVM and currently works at Monsanto. At QCon San Francisco, she will be giving a talk called Contracts in Clojure, Settling Types versus Tests. Jessica, welcome to Software Engineering Daily.
Thank you, Jeff.
I'd like to start our discussion by talking about functional languages. What is a functional programming language?
At the most basic level, a functional programming language can be any language that lets you treat functions as first-class values, that lets you store functions in a variable, return functions from other functions, and pass functions in as parameters. But that's a really bare minimum. I mean, JavaScript does that, Ruby does that, almost everything can. In a more rigorous sense, when people talk about a functional programming language, they usually mean a language that encourages that style of function passing around, storage, composition. And to encourage that, you really need immutable values as the default, if not the only way to store data. And this is often associated as well with a good static type system, but not necessarily. Clojure, for instance, is a functional language. It's a Lisp, but it is dynamically typed.
Why is static typing a useful feature for a functional language?
Oh my gosh, I can totally tell you that. Because it drives me crazy about Clojure. Because when you are passing your functions around, and in functional programming style, you tend to do things in really small pieces. We tend to put small functions together into other functions. For instance, I might want to generate a sequence of numbers, and I might want to pass one function in that says how to tell when the sequence should end, and another function in that tells me how to get from one element to the next. And I often want to put these tiny little functions together. And when I'm passing functions around, if I can't declare the type of the function, it's really easy to get that wrong. To maybe I needed a function from the item in the sequence to a Boolean for the end. And what if I swap that and accidentally pass something that's like from a sequence to a Boolean? And if the compiler can tell me that immediately, then I can find the problem at the point where I passed the wrong function into another function. But in Clojure, if the compiler doesn't tell me that, then I don't find the problem until much later when I actually call the function that was passed in. And it might have been passed 3 or 4 function levels deep, and then I've got to trace back and I've got to figure out where that function came from and who generated it. And that's really painful.
I've heard you talk more broadly about static typing making programmers more productive. You've cited that in several talks and podcasts. In your experience or in the literature that you've surveyed, why does static typing make programmers more productive?
So this research, I learned about it from Dr. Andreas Stefik, who spoke at Code Mesh last year. He'll be at Strange Loop this year. And he does research into programming languages, like empirical research of what really makes programmers more productive or makes it easier for them to understand, to learn programming, or to get it right as they keep going. And consistently, in both his reviews of the literature and his own studies, it's been found that static typing is a small productivity boost, and specifically that the productivity boost comes from using functions correctly. And that comes from having the type declarations in the function signature, that particular piece of statically typed language has made people more productive. And oh my gosh, I totally agree with this, because just yesterday I was writing Scala, and I'm using the Spray Web framework, which drives me crazy because it's got all these like magic DSL-like functions that pull implicits out of the air, and you can't read the function signature and tell what you should pass to it. You have to cast the spell correctly, import the right things, make the right implicits available in the right place. And it boils down to cut and paste, because what can you do when the function that you're trying to call can't tell you how to call it?
One of the first interviews I did for this show was about TypeScript, and TypeScript is essentially a layer of typing on top of JavaScript. And the program manager for TypeScript that I spoke to used a term I really like called developer ergonomics, which is essentially the idea, I guess, kind of what you're saying, of you don't have to cast the spell exactly correctly because the language just kind of helps you figure out the incantation.
Yes,
So,
it makes programming a science instead of a dark art. The magic is when I use the term magic specifically when there's not a way to derive what you should do, as opposed to science where you can kind of logically infer, well, I need units, meters per second squared. So if I take this meters number, I probably need to divide it by two things with the unit of seconds. You can see how the parts fit together, and you can get from one working solution to another similar working solution. Whereas in Spray, for instance, if I was passing back HTML and I want to pass back JSON, I can't just figure that out. I have to look up the spell for it.
right. So, what do you like about functional language support on the JVM specifically, as opposed to something like Haskell?
The JVM has a ton of advantages. It is a really solid programming platform. It has amazing variety of libraries available. Too many sometimes. Oh my gosh. It has great debugging support, great monitoring support, all the different tools that you can use to profile and plug in and see what's going on in the JVM. It's very solid on all the different platforms, and it interrupts. You can do pretty good interop between Scala and Clojure and Java. Going from Java to, don't even do it with Clojure. With Scala, it's tricky. Unless the Scala is designed for it, like the type-safe people have Scala libraries designed to be called from Java. Right, so there's the compatibility between all the different languages and all the different tools written in them. It runs everywhere. People like operations people aren't afraid of the JVM, whereas Haskell is kind of new. And also it means these functional languages that are on the JVM are a fairly easy transition from Java, because underneath them there's all the familiar Java class objects if you're a Java developer.
How do functional languages, specifically on the JVM, make concurrency easier to manage?
Well, step one is immutable values. In Clojure, everything is immutable. Clojure is very good about this. Everything's immutable except a few very specific types, like atoms, for instance, each of which have like little processes around them. There's very clear ways to interact with the few values in Clojure, or the few, what do you want to call them, data holder objects in Clojure that are not immutable. And then when your data is immutable, you can access it from multiple threads. It's never a problem. Scala defaults to immutability. You can make things mutable just by using a different declaration keyword, but at least that's discouraged. I usually have it set up so that turns the variable name red in my IDE, so I know I need to be careful about this one. And it also has things like actors and various tools to make concurrency easier. So these languages are really designed with concurrency in mind from the ground up. Java, it was always possible, but it was never built to be trouble-free. And so we have to have layers and layers of abstraction, and we have to be really careful if we're going to have multi-threaded code.
I'd like to get into some of those complex aspects of Java, JVM concurrency, but let's start with some basics. What is a thread pool?
Oh, okay. I did a talk on this at Strange Loop a few years back. A thread pool is a group of threads. So a thread is, it's a Java concurrency primitive, and it's one flow of execution. If you have multiple threads, then multiple pieces of your program can be running at the same time, or the same piece of code running multiple times on different data, whichever. But threads are an operating system resource. It's much heavier to spin up a thread compared to instantiating any old Java class instance. Therefore, threads, you kind of want to preserve them. You don't want to just use them willy-nilly because you will run out and your computer will run out. They're also kind of expensive, memory-wise.
How do you know how many to allocate? How do you avoid allocating too many or too few?
That is a really hard question, and the answer is different in every case, unfortunately. In the end, you probably don't want to run more threads than you have CPUs, because that's as many as can be physically running. However, often you're using threads to hold your place in your flow of execution while there's I/O going on, while you're waiting for another thread to complete. And so often you'll have multiple thread pools, each of which have approximately as many threads as you have CPUs, one of which is responsible for, say, database access, and it's got its little connection pool to go with its thread pool. And it can hold its place in the flow of execution while it waits for the database. And you'll have another group of threads that serves other purposes. It's dangerous to put a fixed cap on the number of threads in your thread pool because sometimes they start waiting for each other. You can either be really careful and make sure your code never waits for something going on in its own thread pool, or you might hit deadlock, which happened to me, and that was like the whole reason I started studying threads and thread pools and got into JVM concurrency, because I hit the deadlock that comes from threads in a thread pool waiting on each other.
Do you remember that exact scenario? Can you give an anecdote on how that happened to you the first time? Was there some traumatic programming event?
Sure. This was at Monsanto, and we were working with an internally developed but since open source couch database client, I guess. And the client used Scala Z tasks, which use a particular thread pool. And this thread pool, by default, was the size of the number of CPUs, and it was a fixed size. And at certain points, if within your specification of what you wanted to do with the database, you did things like, and then call out to this other function, which then itself started up a little database interaction, then you'd have the outer database interaction waiting on the inner database interaction, which was in the same thread pool. Now, that worked fine on my computer. I had a little test that did like 5 database operations at once, because I was testing that we could do multiples of these at once, which turned out to be a really good idea. And that test ran fine on my computer with 8 CPUs, and it hung on Jenkins. Not just crashed, not just failed. No, it hung forever on Jenkins because the build server had 1 CPU, which is a stupid idea anyway. Why does our build server have only 1 CPU? But even more so, don't ever limit your thread pools to exactly your number of CPUs, because you never want to have exactly 1 thread in them. Why do you have a pool if you only want 1 thread? Right, so that was the scenario, was different behavior on different boxes, which wound up being because they had different number of CPUs. So I could do 1 thing at a time on Jenkins, or up to 8 things at a time on my computer. And I seriously spent 2 weeks solid figuring this out.
How did you debug that? How did you diagnose it? If it took you 2 weeks, I imagine that was a lot of dead ends and wrong turns. Right.
I don't even remember most of the wrong terms, but I know in the end I used JStack quite a bit, and JStack is just a program that ships with the JVM, and you can type JStack and give it the PID of a Java process, and it gives you the thread dump. The thread dump lists the stack traces of all the threads currently running, which is typically dozens. There's 5 or 6 that are going to be internal to the JVM and not yours. And then all your thread pools, and who knows how many threads there are. And most of them are just sitting around waiting for something to do. But you've got to paw through that to try to figure out which threads are waiting on other threads. And you can't tell which thread is waiting on which thread. That would be too easy. So then the next resource is everyone's favorite debugging resource, especially mine, which is println. And I started like adding, okay, print what thread you're executing on so I can figure out which thing is executing in which thread. And I can look at that and the stack trace and try to figure out. And eventually I figured out that I had 8 threads because I could duplicate. Once I figured out that the CPU difference was the problem, I could just like run 9 at once locally and see it hang. And then I could hit it with JStack locally.
Right, got it. So let's move forward to motivate the discussion of functional programming. What is the Java Executor service?
The Java Executor service is a beautiful example of object-oriented composition because it takes a thread pool and a queue to make something better than either alone.
So what are the synergies between a thread pool and a blocking queue?
So the queue decouples insertion of tasks from assignment of tasks to threads in the pool. So this means when you're using the Executor service, you can throw tasks at it all day or be slow at throwing tasks at it. And your thread pool can go about its business of doing as many as it can and hanging, blocking, waiting for you to give it some work when it has more threads than it's using.
What are some benefits to using Scala and Scala's actor model?
The actor model in particular in Scala, first of all, this is a totally different programming paradigm than we're used to. The actor model is object-oriented to an extreme. Because back in the day when OO was first invented, the principle of OO was tell, don't ask. So don't ask your objects to give you their data. Instead, just send them a message and then leave them be. And that's an asynchronous message. This is what actors do. This is exactly what actors do. They send asynchronous messages to each other all day.
Is this in contrast with request response?
Yes. You can do a request response model in the actor paradigm in Akka and Scala, but then you're dealing with futures and it's totally acknowledged, okay, this is asynchronous, it's going to happen later, now tell me what else you need to happen later and I'll do that. But it is very much not call a function, get a return value when you're going between actors. So in that sense, the actor model is not inherently functional, it's very OO. More OO than OO. But it's totally great for concurrency because each actor is guaranteed to execute only on a single thread at a time. This means that within your actors, you can freely use multiple mutable data because as long as the only code that accesses that mutable data is within your actor and not within a future, major caveat, then it's perfectly fine for that data to be mutable. It's kind of like a node in JavaScript.
Right. So you can avoid race conditions.
Yeah, there's no race conditions because only one thread can execute code in that particular actor at a time. That single-threaded but staggered so that it never blocks on I/O. One thing that is very functional in the actor model is that the messages between actors always need to be immutable data. So Scala is really good for that.
What about Clojure? What are some benefits to using Clojure?
The biggest benefit to using Clojure is that it's fast to write. It's fast, it's very flexible, and yet the language is opinionated. So unlike Scala, when you want to do something in Clojure, you will find one way to do it that people use regularly and that the language encourages. And Clojure, being a dynamic language, is very low overhead. Clojure code is incredibly dense. If I have a file with 30 lines of Clojure in it, it might as well be 1,000 lines of Java. I'm not exaggerating. The code it does a whole lot in a few words. And once you're comfortable with Clojure, man, you can whip out a web service really fast.
What is an agent in Clojure?
An agent is, it's an actor. You can think of it as a special case of an actor. An agent is in charge of a piece of data. And if you want that data, you can ask the agent for its data. If you want to change that data, you can ask the agent to change the data. So you send the agent a function, and the agent itself, like an actor, is single-threaded. So it will receive these different messages, which are functions of how to change the data inside it, and it will execute them precisely one at a time.
Could you describe the send and send off thread pools within Clojure?
So double check me, but at least in Clojure 1.6, when you talk to an agent, when you ask it to change its data, you're passing it a function, and you can either pass it a function that's super fast, like increment, and then you would use send, and that would execute quickly.
Okay.
There's a particular thread pool that it uses for send messages, and I forget which one it was. I think it might be a fixed thread pool. But that is intended to be a very fast function. Whereas if you want to ask the agent to update its data based on something that will take a while, either a really long calculation or more likely something that's going to hit the database, then you would say send off and be like, yo, agent, do this thing to your data when you get around to it. And that goes on a different thread pool, which I believe is a cache thread pool.
Ah, okay. So it's more of like an eventual consistency thread pool.
Yeah. It's the you might block, for instance, on a thread in the send off thread pool, and that's a cache thread pool so that it never runs out. Whereas the send thread pool being fixed, it needs to conserve its threads. So that's stuff that should be fast.
Could you describe Clojure's channels?
Channels in core async. It's not a part of the language, but it is one of the core libraries. Core async channels are basically like in Go. Go has channels as a primitive. Core async adds them to Clojure. Channels are a way to send messages between concurrently running processes. If back in the day, if you ever used co-processes in Unix, which I did occasionally to like have a shell script and a SQL session running in parallel, it's kind of like that. When you put a message on a channel for another actor, then your process, by default, if there's no queue inside the channel, will block and wait for the other actor to come get it so you can like synchronize yourselves.
Right, I see. Okay, in a talk that you gave, you said that Java and Scala's parallel streams are much easier to use than the other concurrency models that we have discussed. What is a parallel stream?
A parallel stream, so a stream is, you can think of it as a sequence, but it might not all be in memory at once. You can use it just like a sequence, but behind the scene, it might not all be in memory at once. And parallel streams can execute functions across the items in that sequence at the same time. So you might want to map a sequence. Maybe you've got some integers and you want to do some complicated, random number generation based on each of those integers. Then you would map your complicated function across the stream of integers. And if it's a parallel stream, that function would run on 8 integers at the same time if you have 8 CPUs.
And why do parallel streams use daemon threads?
The nice thing about daemon threads is that they don't hold your program open. They don't keep your process, your whole Java process running if all the other threads have exited. So a non-daemon thread, if it is active, if it hasn't been shut down, then your program will stay open forever. But a daemon thread will not do that. So typically you're working on the main thread. When your main program starts, you're on the main thread, and only if you like spin up some thread pools and stuff will other threads exist. If all the thread pools you spin up are daemon threads, then as soon as your main function finishes, your program will exit. It's crazy how hard it can be to get your program to just stop when you start getting into concurrency. Especially in like Akka with all the actors, and I want them to shut down, but I want them to shut down cleanly. But I've got to deal with the case where they never shut down because the database is hanging or whatever, and then killed. Oh my gosh, it's so hard to just stop.
Right. So, what about a Java future? What is a Java future? We touched on this a little bit earlier, but
Right. So Futures are a concept that exists in a lot of languages. In Java and in Scala, they represent a computation that may or may not have completed yet, and they contain a value if the computation has completed. They will let you get that value out, but if you ask for the value and it's not there yet, then your thread will block until it is there. You can do that both in Java and Scala, but in Java, that's pretty much all you can do. Also, that value may be an exception in both Java and Scala. So if you sit there and wait for it and it throws an exception, great, you'll get the exception. If you never sit there and wait for it, if you just wanted the computation to happen in the background and you never ask it for its result, that exception will disappear into thin air. By default, it'll go to your log file, but that's it.
Across the different functional languages and features we've discussed, do these languages and features simplify the failure modes that a programmer can encounter?
There are some features that deal with failure modes. Overall, concurrency does not make any sort of failure easier to diagnose or even to notice. But this is one of the things that functional languages offer. There are features or styles or libraries to deal with the fact that errors get way harder as soon as you get into concurrency and doing asynchronous things. One of my favorites is the either type, which says errors are data too. And just because you had an error doesn't mean you should throw an exception and do crazy things to your execution flow and jump back who knows how where, because pretty soon you get to the top of the thread and you're just writing it to the log. If you treat errors as data and instead of throwing an exception, you wrap them in an either data type, then you also wrap your successful results in an either data type so that the return value of your function is either an error or a successful result. Then you keep your flow of execution the same in the error and success cases, and you force the people who called your function or ask for your asynchronous result, if it's in a future, you force them to acknowledge that error is a possibility and to program something in to deal with that one way or another. It's like Java checked exceptions sort of tried to do that. They tried to force us to deal with the error cases, but they're horrible.
So are you saying that you use exception handling in a different way when you're doing functional programming?
Yes. Functional programming, because you've got your code is flying around all over the place, and there's functions just going every which way, and it's really hard to keep track of where this particular code that's executing came from. That's a complication. The simplification that we make, there's several things that we do to make things simpler to compensate for that. Immutable data, totally the number one of those. But another one is, okay, let's not have exceptions screwing with our execution flow, because who the heck knows who's going to call this function or on what thread. So if it throws an exception, I really have no idea what's going to happen. Instead, let's treat the errors as data and keep the execution flow the same so that if I have an error, I will return an error and things will be otherwise normal and sane.
How does Java concurrency, or I should say JVM concurrency, differ from the notion of concurrency in Node.js?
I am not a Node programmer, but I can tell you that as far as I know, Node.js, just like JavaScript in the browser, has exactly one thread that's running your code at any given time.
Does the single-threaded nature of Node appeal to you at all as somebody who is deftly aware of all the hazards of multithreading in Java?
Oh, totally. Yeah, if you can get away with that model of just having one thread and only spinning off I/O processes, it's way simpler. And the actor model does this too. If you can just stick your code in an actor, and then you can still have it, you can still be flexible on the order in which things happen. But if you don't have to share threads, then mutable data isn't a problem.
Is there a Java single-threaded event loop type of library or system that is similar to Node.js?
If you ever programmed in Java Swing, you could think of it that way. I mean, as far as like, because in Swing there was the, what do you call it? The event thread. There's one thread whose job is to update the UI, and anything that was going to be slow, you would spin off into a different thread. So it was kind of like that. And I don't know if there's like a node for Java library. What would that be? It would be like the opposite of JRuby.
You also gave a talk called Functional Principles for Object-Oriented Development. What lessons are you trying to provide in this talk?
That is my favorite talk ever, by the way. And I think I've done it 13 times at least. And it's different every time because I keep learning more stuff, more lessons from functional programming that totally apply everywhere. I think a lot of the stuff that we do in functional programming that we label as functional programming principles are really just good programming principles. Immutable data is the biggest one. There is nothing stopping you except pain. If you're in Java, it's just more work because it's not the default.
Or static typing, as you already mentioned.
Yeah, yeah. Yeah, you can take a lot of these things that are useful in functional programming, and they kind of come along with functional programming because if you don't use them and you pass your functions around willy-nilly, you will go insane. Or if not you, then anyone who tries to read your code and change it. But a lot of those are just really good programming principles. The biggest one, I think, is avoiding cyclical dependencies. Currently, I think that is at the core of a lot of the things we do in functional programming. Take mutable state, for instance. Mutable state creates an invisible circular dependency between everything that might read the state and everything that might write to it, which is everything if it's mutable. So there's all these, you suddenly, you who have this state and are just reading it, suddenly your actions are dependent on anyone else who has access to that and might possibly write to it. They can all affect your behavior. That's a circular dependency. So Bob Martin compiled the 11 principles of OO programming, one of which is the dependency inversion principle, which says that, okay, I'll do it in my talk voice. High-level code should not depend on low-level code. Instead, both should depend on abstraction. Basically, it says you shouldn't depend on the implementation of what the library you're using. You should depend only on its API. And in order to do that, you should physically not be able to access its implementation. You should only declare a dependency on an API, and then that library then should just implement that API.
Right. I like that you adopted Bob Martin's theatrics along with the the explanation of his principle. Something that you focus on in that talk is a concept called data in, data out. What do you mean by data in, data out?
Data in, data out is, functional programmers call this referential transparency. And it is one of those core mechanisms by which we stay sane in functional programming. And it says most of our functions should take in parameters, return a value, and do nothing else. They should not be influenced or influence anything in the outside world. It's kind of the opposite of encapsulation. Encapsulation is you can't see into my class, function, whatever. Data in, data out is about isolation. It's about my function doesn't see out. So it never accesses global data. It never reaches into a database or a file. It never updates its parameters. That's just rude. And that means that all of your function's dependencies, everything that could possibly change what your function does, is in its parameters, which makes it super testable because you have complete control over those. For the same parameters, it always gives the same result.
How do you contrast isolation and encapsulation?
Isolation is I can't see out. Isolation is within my function. I don't see the outside world. Haskell is maybe the only place I know of that you actually get this. Well, and Elm and some other ML languages maybe.
Let's discuss the talk that you're going to give at QCon San Francisco. It's called Contracts in Clojure, Settling Types versus Tests. What is a contract?
Contracts have been around for ages, and it's basically like your function says, yo, if you give me stuff that meets these conditions, then I promise to give you output that meets these other conditions. It's stronger than types in the sense that you can add conditions that you can't check in a normal type system. Like my function could require that you pass it a list that isn't empty, or a string that only contains a limited character set. And then on the way out, it could say, well, I promise to give you a string that's the same length as the one you sent me in.
And so the subtitle is Settling Types versus Tests. What is the disambiguation that needs to be made versus with types and tests?
That's a good question. So a couple years ago at Strange Loop, Amanda Losher and Paul Snively did a talk about types versus tests, the epic battle. Types and tests are both ways of ensuring program correctness, and they do that through fairly different mechanisms. Types being enforced by the compiler, so you're sure they're correct or your program wouldn't even run, and tests, of course, being a lot more flexible. Personally, I find that contracts, which are basically tests, assertions embedded in the code, but run through tests, to exercise through tests, I should say, to make sure that they're correct. I find these give me the best of both worlds. The best of types is, as we referred to earlier, being right in the function definition and helping the programmer use the function correctly. You can get that with contracts if they're implemented the way Clojure's Prismatic Schema does them. It embeds the contracts in the function definition. And I think that gives me the best of types. And it also gives me the best of tests in that it's completely flexible of when I want to enforce them, how rigorously I want to enforce them, when I want to add them even. Because I said that Clojure was great at being fast, that you can really do a lot in a few lines and be efficient once you're good at it. And part of that is the dynamic typing, is not having to declare your type. So as you're experimenting with your program, you don't have to specify the structure of what's being passed in. It's Clojure. You just pass maps around, and dictionaries, hash maps, whatever you want to call them, all the time instead of having to define a type. That makes it faster to work with the code and change the code. But once you want to put this in production, or once it is in production, then you can harden that and increase your guarantees by gradually adding in these contracts. So I think it lets me get actually more reassurance than types, because I can declare things in these contracts that I can't declare in types, like the length of lists. But it doesn't force me to get that reassurance before I run my program. I can still be quick at running it, be quick at experimenting, decide when it's useful, and then add as much reassurance, as much verification of correctness as I want. So in the contrast of types versus tests, or the contest of types versus tests, types are like, find your errors early, and tests are like, find a more variety of errors in a more flexible way. Okay, I've frankly totally come down on the side of tests in that, except for that beautiful function inline, this is how you use the function, let the programming language help you use the function correctly. And I can get some of that with contracts in Clojure.
So more specifically, what is Prismatic's schema library?
This is a library open sourced by Prismatic, and it provides just a couple macros. It's a fairly small library. It's really just a couple of macros that let you inline these assertions in your function declaration. So right where a return value belongs and right where parameters are declared, you can put these quote-unquote types in there. And then the Prismatic schema provides a style for doing this. And the macros that typically you configure it so that the contracts are only ever checked in test. Or sometimes, at interface boundaries in production, you might turn them on there so that they don't impact your production performance.
So I heard a podcast where you talked about Monsanto and learning Scala simultaneously while you were learning principles of biotech. And I think people are commonly thrust into this type of situations, particularly programmers who are just programming, but they're in some super specific domain, and so they have to often learn two complex things at once. Like you said, you had to learn Scala and biotech at the same time. Do you have any tips around this, like principles for how you can maybe synergize learning two disparate, complex topics at once?
Yeah, that's a good question. I almost hate to say this because I don't want people to figure it out, but I'm starting to think that the right way to hire programmers and to specialize within our incredibly broad discipline is on business domain. I mean, if I were hiring in, I don't know, finance or some fairly specific business domain, I wouldn't look for a Java developer. I would look for a developer with experience in the finance domain, and I can teach them the programming language because, frankly, that's easier in a lot of domains, not every domain.
So did you find that to be the case in Monsanto? Or did you already have bio experience?
Actually, yes. I mean, I didn't have biotech experience, and it hurt. But the two of the best developers on that project, probably the two most essential ones, were biologists who learned Scala. And they were just drastically more productive. I mean, we could come behind them and sort of clean up the code in some cases and like add error handling and make it more rigorous. But their understanding of the domain was frankly more valuable than our professional software developers' understanding of the programming language.
I'd love to hear more about that because you're currently building microservices on AWS, assuming you're still doing the same thing you were when I heard that podcast. So these developers that have started out as biologists and have picked up software skills, do they have any trouble understanding principles of building a microservices architecture?
In software, we talk a lot about quality and building things with security first and with error handling first or robustness. And if you take someone who's relatively new to programming, yes, that's harder for them, but pairing is perfect here. Pairing really transfers that knowledge pretty well. And also, I can come back and refactor their code and put more error handling around it. And I can once the expert in biology puts it into code, then I can understand it. I can understand it thoroughly because it's right there. It's enumerated in a language that I know that I can count on. The beautiful thing about programming languages is they're generally not ambiguous because the JVM and the computer interpret them very, very specifically. And once the biologist has encoded that stuff, I can come back and refactor it without messing it up. That's so much easier than learning the biology in order to write that code in the first place.
Tell me more about the microservices architecture that you're building.
We are working on a platform for deployment and running and scaling of microservices within AWS. So I think a lot of companies are doing the same thing because the infrastructure doesn't exist. Some people have open sourced their solutions, but their solutions are rightly exactly what that company needed and not further. So every Monsanto is building their own, looking for making it easy for a developer to spin up a microservice. We kind of want to take away the disincentive to decouple and separate bits of code by making it super easy to just pop out a new project and get that deployed in the VPC along with everything else. And it'll automatically scale and it'll automatically put its logs in the right place and it'll automatically be able to find its other services that it calls. There's a lot of work around deployment, really of anything, but it totally shows in microservices because you've just scaled up the quantity of things that you're deploying. getting.
Are you using containers?
We are using Docker containers, yes.
Okay. Do you use Amazon's ECS service?
We're not. We're not. So one of the challenges of building this, and one of the things I think Monsanto is doing well, is when something like that comes out, we put it on the list to, okay, now that this general tool is available, can we use this to replace some of the stuff that we've written internally? Because what we want, what we need isn't out there yet, but when what we need is out there in an industry standard way, it's time for us to throw away our code. That can be hard for people, but it's a great idea. Every line of code is technical debt.
What are the benefits to using containers?
Hypothetically, you get isolation, as in only the ports that you specify to be open are open. You do get isolation in the sense that it's harder to mess with other programs that are running in the same box. Like you're not sharing a file system unless you explicitly set that up. The other hypothetical benefits are you should be able to run it locally or in the cloud, and it would have very similar environments. Like if your container has a JVM in it, then it has that locally and it has that in the cloud. Unfortunately, that means you have to spin up a VM locally to run it in. Yeah, but that's a good idea for development practice anyway.
So in an interview I heard with you, you mentioned that you found event sourcing to be a important aspect of building microservices. What is event sourcing?
Ooh, I love event sourcing. Event sourcing is the paradigm that history is the sum of all the events that have ever happened. And you can look at your data the same way as the sum of all events that have ever happened. So this customer record, it's not just one thing. It's not just one card in your Rolodex that changes as the customer's moves to a new address. Instead, your customer is a sum of all the interactions you've had, of its original insertion, of each address change, plus each phone number addition, plus each contact record, plus each whatever the heck would affect the data in the customer record. The record can be viewed as a sum of all of these events. Within your program, an event sourcing model says, okay, I take some data in and my output is events. When your function, when all it returns is a series of events, and then in order to have an effect on the world, something else says, okay, apply these events to the database, or pass these events to everyone else who needs to be notified. The beauty of that is that you can test that function, and when you test its output, you're testing not only what happens, what was returned, but also everything that didn't happen. Because you can also say, well, nothing other than this one customer could be impacted by these events that were returned.
Are there any synergies or things we can discuss around functional languages with event sourcing and microservices? What are the synergies between these different domains?
I think they're there. Well, I know they're there. For instance, a function that can be data in, data out, and still produce events, which will eventually affect the world. That's a synergy. I think there's more to it than that. Right now, in fact, sometime today, the video should come out. I just gave a talk at React Rally about React and Elm, in case I wasn't talking about enough languages already.
No, it's great. I was going to ask you about this, actually.
Okay. And Elm is purely functional, and React is closer to functional than the other JavaScript frameworks. If I had to write JavaScript, I would do it in React. And that uses an event sourcing model in the sense that all impact to the model comes in through actions, and that kind of impact to the model is the only way to change the UI. And then the UI can specify, all right, if you click this button, then this action happens. But that's a very explicit event loop then. So React and Elm on the front end are doing event sourcing. And I have this theory that I haven't written up yet, that architecture of events come in which affect a single model, which impacts multiple UIs or UI components, which then allow for more actions to be triggered by the user, and these come in as events, that this model can scale up because some of those events need to get sent back to the server, while at the same time, some events from the server can come in over WebSockets, for instance, and affect the model and therefore the UI of the front end, that this can scale up. You take, if your program is based on events, your whole architecture is based on events, and that's how things happen, then you can filter those events outward and transmit some of those. You can take other events in from the rest of the world in a very controlled, one at a time, traceable, debuggable manner. And then if your backend is also event-based, you can use the same kind of architecture scaled up in a fractal manner.
Yeah, and I think React is going to be a really interesting leading indicator to watch. It seems like Facebook has got some really ambitious plans for what they're doing, and I really look forward to seeing how that stuff develops. Software Engineering Daily is going to do a week of shows about women in tech, and my personal motivation for doing this is like just seeing the underutilization of the workforce, like seeing women underemployed and underappreciated in the community, and it just like damages the utility of our programming society. But like, so women I talk to about this, they'll often either say, that's great that you want to talk about this, that you're doing this, or they will say, like, I don't want to hear about that. I don't really care. I just want to do the programming, and that's how there's going to be a sea change. It'll be, women actually just doing work instead of acknowledging this issue. So do you think that's a fair delineation to draw between kind of two separate camps in this community? And is this even something that you like to discuss? What are your thoughts on this?
Good question. So I used to be in the latter group. I used to be like, blah, blah, blah. I just want to program. I'm having a good time. The system is working for me. Therefore, the system works. But I'm not there anymore. I've sort of looked out and observed that other women don't have the same experience I do. I'm like, in many ways, I'm in a very small percentage. So programming is easy enough for me that I've always been good at it, good enough that no one ever questioned my competence. And if anyone ever did, everyone around laughed at them immediately. And I'm extroverted, and I don't mind being the center of attention. And these are all like qualities that some women possess, but as you add them together, the percentage of women who are comfortable like this goes down and down and down until really our industry is a hard place for the majority of women to be. And just because I'm not in that majority, I've recently, last 3 years, I guess, learned to open my eyes and see that other people are affected differently. It's not going to be solved just by keeping our heads down and waiting for it to go away. Now, if, as a woman in programming, that's what you want to do, and you just want to program and you don't want to deal with this, fantastic. You're helping by existing. Go with that. Whereas if we want this to change, we have to look at the system and the incentives that are in place. This applies not just to women, but to all minorities, and also to quote-unquote minorities, people who currently aren't welcomed by our industry as it works now, such as introverts, who are extremely precious and we really need to be nice, and also people who aren't geeks, people who aren't into Star Wars and Star Trek and Magic the Gathering. And we have all these assumptions. There's a culture around programming that we assume other people have this context and share all these interests that are totally not relevant to programming and totally don't even matter. But yet people feel left out if they don't share them. So as we're looking for diversity of thought and we want our industry to be welcoming to more people, all of these things we can work on changing. A lot of it is just snowballs. I mean, why do we assume that all programmers are geeks? and specifically like Star Wars? Well, because somehow by historical accident, a large majority of programmers did like Star Wars, and that snowballs because then we bring in other people to the field who like Star Wars or are white men. And then the majority gets even stronger, and then the people who don't like Star Wars don't get the references, and people make fun of them. What do you mean you don't like Star Wars? How could you even be in this job? And seriously, that
has literally happened to me.
I'm not surprised.
I've never seen Star Wars,
well,
and that's happened to me.
Jeff, that is okay. And what's not okay is this assumption that everyone shares that interest. Just like there's an assumption when you tell a joke that either you have a penis or you think it's funny to talk about them. And personally, and you can edit this out if you want to, but personally, I do find it funny, but that's that's a small minority. And whenever we tell a Star Wars joke, we are subtly increasing a feeling of I don't belong here among people who don't care about Star Wars. And whenever we tell a sexual joke, we are subtly increasing the feeling of exclusion among people who are a different gender than the majority.
Yeah, I'm doing an entire week of the theme of women in tech. It'll be just, talking to women who are, just like you, and they're developers. And, what are the questions to ask? What are the things I should even be discussing?
So one thing that you should probably cover is why women-only events are important. Oh, Stereotype Threat. Cover Stereotype Threat.
So just for listeners, Stereotype Threat is a situational predicament in which people are or feel themselves to be at risk of confirming negative stereotypes about their social group. Interesting.
Right. There's some good cartoons out there of male stick figure is doing a math problem on the blackboard, and the other stick figure is like, you're bad at math. And then like a feminine stick figure does the same thing, and he's, women are bad at math. When you're the only one, there's that generalization. There's more to it than that as well. There's the part where, so Llewellyn Falco has a beautiful blog post about going to Zumba and being the only man, and how awkward he felt, and how he didn't want attention called to him. He wasn't comfortable being a center of attention. He just wanted to fade into the background. And when a woman goes to a programming meetup and she's the only woman, subconsciously, and this is part of Stereotype Threat, subconsciously there's this question of, okay, there is an obvious difference between me and everyone around me. Is that relevant? And every time people treat her exactly the same way as anyone else in the meetup, that, okay, maybe it's not relevant, maybe I can belong here, maybe it's okay. But as soon as that difference is emphasized in any way, and this is where, like, your dick jokes come in, any mention of genitalia or any sexualized picture of a woman on the slide or on the wall, all of these emphasize the difference and just bring it to her attention and make her feel like she doesn't belong. Also, that question of, is this difference relevant? There's a tension there that makes it hard to relax, and it makes it hard to learn. So when a woman is the only one in the meetup, she is having a harder time. More of her brain is occupied by, do I belong here? That makes it harder to learn from what's going on, which then makes it harder for her to learn how to program. This is where women-only events are crucial. Or even just mostly women, where it's for women and you definitely belong here because that's why we're doing this at all.
This is QCon week on Software Engineering Daily. And you've been to so many conferences. How can a developer optimally take advantage of their attendance at a conference?
I would say step one is talk to people, meet people, especially if the conference is videotaped. Go to talks or hang out in the hallway and talk to people. Go to talks that you wouldn't watch on video. I love that most conferences are publishing videos of their talks now, so you can really focus on I am here in a building with a whole bunch of people who are my peers who have experiences that are very relevant to me but not identical to my experiences. A great time to ask the person sitting next to you what they got out of the presentation. I would say follow the Twitter hashtag and tweet what you learned. That's another way to make connections. I always bring a Sharpie to conferences and write my Twitter user on my badge if it's not there already.
Nice. Good tips. Okay, cool. Well, Jessica Kerr, thanks for coming on Software Engineering Daily. It's been a real pleasure talking to you, and I'm a huge fan of your talks on YouTube, so I'll put some of those in the show notes, and I look forward to seeing you at the conference.
Thanks, Jeff. I look forward to seeing you too.